Hi, my name's Michael, and in this video, I'll be doing question number 3. In this question, we'll be looking at the interaction between Jupiter's magnetic field and one of its moons, Europa. The goal of this problem is to understand how the magnetic field of Jupiter's tilt relative to its axis of rotation interacts with the conducting subsurface ocean on Europa. Because Jupiter's orbit is at an angle to the plane of Europa's path, this causes Europa to see a time-varying magnetic field from Jupiter. Here we see a sketch of the magnetic field of Jupiter and its moon Europa at different points in its orbit. As we can see on the left side, the magnetic field is pointing away from Jupiter, and on the right side, it's pointing towards Jupiter. In the bottom right, I've done a very rough sketch of the magnetic field as a function of time. We can see that the x, y, and z components of the magnetic field vary as Europa goes in its orbit, and the magnitude of the magnetic field varies a little bit based on how close Europa is in its orbit. Because we have a time-varying magnetic field, we can see with Faraday's law that it will induce an electric field. That electric field can source a current. This current is related to the electric field and the conductivity by Ohm's law, which tells us that the volume surface charge density is equal to the conductivity times the electric field. In this next figure, we have an example of Jupiter's magnetic field passing through Europa. Assuming that Europa is a sphere, we can imagine an Amperian loop going into and out of the page. If we assume that the magnetic field of Jupiter is increasing in this picture, then we can use the right-hand rule to determine that the induced current will go into the page on the top of the picture and out of the page on the bottom. When the Galileo satellite passes near Europa, it will see a different magnetic field than expected due to the induced current. If there wasn't a subsurface ocean on Europa to conduct the current, the Galileo satellite would only see the normal magnetic field produced by Jupiter. Given the measurements of Galileo, we could find the induced current on Europa, and along with the electric field at that point, we could again use Ohm's law to find the surface conductivity on Europa. The context of this problem is maybe fairly evident in the problem itself, but the discovery of a subsurface ocean on Europa gives us the ability to discover other subsurface oceans on other bodies in space, which could help us immensely in things such as finding life elsewhere in the universe.